Okay, hi everyone, and today we're just going to do a really quick video on managing cognitive load in children. Now, cognitive load, it's the amount of information that working memory can hold at one time. Cognitive being the way in which we think about things, and load being, the amount of information. Now, not all cognitive load is bad. Some cognitive load is required for us to learn in the first place. However, the problem arises when the load, the information coming in the first place, exceeds our capacity of that individual processing it. What we do need to understand when we're talking about cognitive load and we're talking about working memory and processing is we need to understand what memory is. Now, there are three types of memory that we need to understand together in order to figure out what it is we are talking about when we're talking about children with diverse learning needs and we're talking about learning. So we're talking about memory with encoding. Now, encoding is the first part of memory. We've got to pay attention to something in the first place to get it into our short-term memory. If we're not paying attention to it, it's not going to be retained at all. So we need to pay attention to it, we need to encode it. We then need to store it within our short-term memory to go to our long-term memory in order for the third stage is retrieval of that information. Now, memories are not stored in one particular area. There are different areas in our brain that do different parts of our memories. If you look at the frontal lobe, the area right at the top of and the front of our brain above our eyes, this deals with our working memory. It is an executive function, is our working memory. But we can also look at memories that are declarative, and this is our conscious memory, and it is about knowing what something is. And you can see that some declarative memories are within our frontal cortex. But we also have memories that are unconscious, and that is knowing how, and that is all about our implicit memories, and we can see these here are in our basal ganglia. And we can also have our procedural memories, which is a little bit down here in our cerebellum, but of course our hippocampus also stores some declarative memories as well as learning and memory. Our amygdala is our emotional centre of the brain, right in the middle of our brain, and that is to do with our emotional learning. Our temporal lobes here, a lot of it to do with our memory, and our hearing as well is autobiographical memory. So there are many different parts of our brain that are to do with different types of memory. Now, when we're talking about working memory, we are talking about this prefrontal cortex up here. So those of you who have done a psychology degree will have come across this model before. Baddeley and Hitch's working memory. So as we say, we have to encode information to come into our memory. And this is from environmental stimuli, what we see, what we hear, what we taste and what we touch. And this is our sensory memory. And this is a really small capacity. We're talking about milliseconds here. If it is unattended, if the information is not selectively attended to, we absolutely and utterly forget about it. And this goes to show why some people experience different memories of exactly the same event, because if we're not paying attention to the same things, what we see or what we hear, then we're not going to have the same memory for it. So we have to selectively attend to that information in order for it to pass on to our working memory. Now, our short-term memory and our working memory are different but very similar. Now, our short-term memory is about holding 7 plus or minus 2 bits of information. Now, if I said to you 4, 6, 8, 9, 3, 7, 4, how many of those bits of information can you remember? Now, if you start rehearsing it or you start visualising it, that is where we use our short-term memory. We have to chunk it, we have to rehearse it in order to get that information into our long-term memory. And this is what we call encoding. Okay, we have to get information from our short-term memory to our long-term memory, and the way in which we do that is by this rehearsing. Now, if I asked you to hold and manipulate information, this is our working memory. So if I said to you 7, 4, 8, 3, 2, but now take each number and add 1, what number do you have? This is working memory. So you should, with the number 7, 4, 8, 3, 2, you hold it, you manipulate it, you add 1 to it. What I'm asking you to do, the number you should have is 8, 5, 9, 3, 2. So working memory is visual and it's auditory. It's about hooking that information and getting that information into our long-term memory. So there are distinct differences between our short-term memory and our working memory. But essentially, memory is about an active dialogue between our working memory and our long-term memory. We have to link information in our working memory to what we know in our long-term memory in order to learn. Schemas are essentially categories. It is, like I just said, why we experience the same event, but why we take home different messages from it. What we attend to in our environment is absolutely crucial. So you have to sense something, you have to pay attention to it, and then you have to recall that information from that long-term memory, that episodic or semantic memory. Episodic memory is your own experience of something. So where were you when the Twin Towers fell down? Where were you during SARS? What did you do for Christmas last year? What did you do for Chinese New Year? Okay, episodes of something, that's episodic and it's specific to you. Semantic memory is all about knowing things. So you can then activate a schema for, let's say you saw a dog. You activate your schema, your category for animals. Okay, this schema, this category is in your long-term memory. What you're paying attention to is in your short-term memory or your working memory. Okay, so you have something in your working memory, you have to retrieve it from your long-term memory to understand the world. So schemas are all about how we make sense of the world. We have to learn and we have to organise that information. So you see a dog and you get told that's an animal, you have a category for animals in your long-term memory. Oh, why? 4 legs, ears, tail, it's an animal. Okay, I know what to do with that. And as you learn, you expand these schemas or categories. You either add them to it. If you see, for example, a duck, you think, oh, okay, it's got 4 legs and it hasn't got fur. So you can either expand that schema for animals or you can create new schemas. And this is exactly how we learn. We learn about linking information from our short-term memory to our long-term memory. So essentially, how we present this new information is absolutely essential. So learning is active and fluid. Essentially, what we are doing is making connections between new information coming in and old information we already have in our long-term memory. The capacity of what we can hold on to severely impacts our learning, because if we can't hold on to information that's coming in, that new information in our working memory, we are not then processing it, we are not creating schemas, we are not linking it to our long-term memory. So when it comes to being able to take it out of our long-term memory, it's not actually there. So we really need to make connections between our working memory and our long-term memory. So some really important aspects of the classroom is all about strategic practice, it's about scaffolding, and it's about feedback. So when we're talking about strategic practice, we're talking about really explicit, clear instructions that maximise the understanding and the retention for the students. When we're talking about scaffolding, we're just talking about the teacher adding support to enhance learning. So essentially building upon brick by brick from what you've learnt before. So strategic practice, scaffolding, feedback is all about how we present that information, how we can build upon brick by brick to really help in a very clear way the student learn that new information, understand it and retain it. So when we talk about cognitive load, there's three sort of main areas. We talk about the intrinsic load, which is all about the individual. How hard is the concept being taught and how capable is the child? So we're talking about complexity of the information, and of course that individual has no real control over how hard they find it or how easy they find that information. The domain load is all about understanding. It's about those schemas, those categories, and how quickly we can access them from our working memory to our long-term memory. And then lastly, the extrinsic load. That complexity of the information, but it's out of our individual control and it is controlled by the teacher. It is about the information that is being presented to us. So if we think about an example, learning the names of the planets of our solar system. So that intrinsic load is all about that individual, the amount of information that they have to learn. Now for some children this is going to be really easy, for others it's going to be really difficult. And this is where the differentiation comes in. For those of you who have gifted and talented kids in your class who have really good working memories, they can run with it. They really understand it. They only need to be told once. For others in your class, those who have maybe specific learning disorder, their intrinsic load, how easy they find that information presented to them is going to be far more complex for them and is going to be far more difficult. So the intrinsic load for each individual is going to be different. The amount of information that is to be learnt from that for that particular child. The domain load is the processing of that information to be learned, how quickly they can understand it, get it, and remember it. And then we have the extrinsic load, the environment, and this is controlled by the teacher. What is going on in that classroom? How are you presenting that information? Are you using PowerPoint? Is that PowerPoint overwhelming? Is the noise level going on too much? And if we think about that working memory again, it's information coming in through our eyes and from what we hear. What is that external load for that particular individual? Now, children will differ within sort of moment to moment, subject to subject, and also day to day on these three. So the extrinsic load might be different on a maths subject than it is for a geography subject. That processing of the information, that understanding might be different depending if you're looking at numbers or if you're looking at words. And of course the extrinsic load changes constantly. What method are you using to present that information and what else is going on in that classroom? We also know that cognitive load is impacted by that child's anxiety, that child's stress. So again, it will change from subject to subject. If they're really good at maths or really poor at maths, that anxiety level will have an effect on their cognitive load. So really what we're doing within the classroom is teaching is all about managing that cognitive load, understanding and managing that task difficulty for each child so that we can reduce that extrinsic load, reduce that noise, reduce all that outside sensation that we don't need so that our retention of the information is increased. Now, there are ways in which we can do this within the classroom to reduce that cognitive load. Coherence. Make your classroom a beautiful setting. Make sure that it is a nice quiet environment, that you are presenting only particular images that are needed, that it's quite a natural environment. And we've certainly moved away from those classrooms that are really busy, have lots of bright colours. Okay, so really it's about coherence, what it is that these children need to learn. And of course, this helps all children in the classroom, not just children who have issues with cognitive load. Signalling, highlight what it is that they need to know. This could be underlining particular parts of the question that are important. It could be making a particular word highlighted within a colour or making it bold. Okay, so really identifying the key points that that child needs to take away and removing all the other unnecessary bits of stimuli. Reduce. If you're using PowerPoint slides, you know those who are good presenters and those who aren't good presenters in the way in which they present the information in the first place. You either have graphics and narration, so no words written on that page. So for example, there's a graphic here and I can say the traffic light sequence to you. This is a red traffic light, this is a green traffic light, and this is an orange traffic light. So we can have graphics and narration, or we have this spatial continuity. So words should be placed next to the graphics. So for example, your text goes right next to what it is that you are talking about. So the red traffic light, your text would be red traffic light. The green traffic light would be green traffic light. The orange traffic light would be orange traffic light. Okay, so you are again reducing that cognitive load so they're not trying to figure out what part of the information goes with what graphic. So the four things we're looking at is the coherence, the signalling, reducing all that external input to what it is you really need to know, and thinking about how you are presenting that information. So teachers need to understand the four common signals on working memory and the overload. This incomplete recall. Children begin writing a sentence and then they forget what the rest of that sentence is. They may put up their hand, but then when you call upon them, might not remember what it is they want to say. And these are all working memory failures. Failure to follow instructions. You might tell them to get out their books, open to page 32, read the paragraph and then answer the four questions. If they are not following those instructions, if they're forgetting what it is they're doing, then this is a working memory issue. If they have real errors keeping track of what they are doing, keeping pace, losing track of the steps to complete what it is they're supposed to be doing, if they're repeating certain steps because they can't remember what they've already done, or they're constantly having to start over because they can't remember if they have completed that stage of the task or not. If they keep making these place-keeping errors, again, a sign of working memory failure. And then task abandonment. If they just completely give up, they can't remember what they're doing, they can't remember where they started, where they got up to, they sit down the next day and just think, oh, I can't remember where I was, and then they just totally switch off. Task abandonment. These are all things to recognise within your classroom for working memory failure. Now we're going to go on to specific neurodiversities. So when we're talking about children who have ADHD, you'll notice that these children don't have particular difficulties with their short-term memories. These children will be able to verbatim repeat back to you a string of numbers. What they do have problems with ADHD is manipulating both verbal and visual information, and actually with ADHD it is more visual problems than it is verbal problems. They have that working memory issue. They struggle to hold on to, keep in mind and manipulate information. And if we're talking about ADHD, we are just talking about a disorder of self-regulation, a disorder of executive functioning, and working memory, as we know, is an executive function. In autism, there's been some wonderful research, a huge meta-analysis looking at nearly 1,000 individuals with ASD. And we can see that there is, again, a general impairment in working memory. And again, same with ADHD, visual working memory was more impaired than the verbal working memory. when we're looking at children with dyslexia, they really struggle to link their working memory to their long-term memory. And we see a lot of this in reading comprehension and reading fluency. Working memory really is about how we hold on to that information and use it to understand what we have read earlier and what comes later. So we are holding in mind and manipulating information. Students really need strong decoding skills in order to remember what they've read, to hold on to the different characters, and then be able to proceed with what they're reading. So we can see with impairment in reading, this working memory is really important for things like reading comprehension and reading fluency, being able to hold in mind and then manipulate that information. When we're talking about dysgraphia, again, holding and sequencing sounds for spelling and also for composing those sentences, holding and connecting ideas in written text. You've got to remember your sentence, remember your capital letters, remember your punctuation, and then get it all down as fast as you can with writing it. You know, you may not be able to remember what the word looked like, how you're supposed to spell it, and then, you know, everything goes out of the window. You can't remember the comma or, you know, what it is you were supposed to be doing. So working memory has a great impact on dysgraphia. And again, dyscalculia, you make errors when you're translating numbers from verbal to written form. These children have great difficulties in sort of storing numbers, retrieving numbers, a combination of that working memory and linking it to their long-term memory. Now, it might be that they remember their times tables on one day and can't remember the times tables the next day. And as things get more complex in maths, you will see that these children just don't have the basic understanding, this maths fluency, in order for that automaticity of retrieval of those basic math skills. So again, working memory plays a huge, an important part in our understanding of maths. Now we can see developmental coordination disorder or dyspraxia. We can see the fine motor skills and the gross motor skills, and there's some research that suggests that these very poor visual working memory skills, they can't coordinate what they see, what they touch to, you know, their long-term memory, what they are supposed to be doing. They don't have those fine and gross motor skills, and this is to do with being able to manipulate what they see and this visual spatial information. So processing speed and working memory, and I've done another separate video on processing speed for you. They are both about information processing, but they are different components of it. Working memory is that initial identification, registration, but specifically we're talking about the manipulation of information, and of course this is verbal or visual information. Processing speed is more about the rapid identification of information, and we use this for decision making. Those who have fast processing speed don't have to hold on to as much information in the working memory. They don't have to store it in their short-term memory or their working memory. They don't have to repeat it as much before they start, you know, processing that information. If we see children who have slow processing speed, we can see that their working memory or their short-term memory, you know, they're repeating it over and over and over again because they are, you know, their processing speed is just not matching all that information coming in. And then you see if they're not repeating it, they're losing that information. So the information is then just gone. So processing speed isn't actually a good predictor of how quickly somebody is likely to learn something. This is more to do with our working memory. Now, working memory has a huge impact on academic performance. So we have talked a little bit about 4 other influences on our working memory: our level of anxiety, our level of depression. There's also some research on pain and also on multitasking. We know that the more information we're juggling, the less likely we are to get that information, to attend to it and get it into our working memory in the first place. Again, it comes back to understanding encoding of that information. So when we're looking at particular issues within the classroom, if individuals are forgetting tasks, think about, really brief examples, really simple instructions, breaking things down into specific steps. If they're not meeting the demands of the activity, reduce that complexity, increase that familiarity. So it might be that we're doing that scaffolding, or we're doing sort of more strategic, more explicit, small parts of giving instructions in the first place. And if these children are losing place in the task, externalise that working memory. Give them lists that they can cross off, or stickers that they can stick on to say, yes, I've done that task. Yes, I've done that task. So we're thinking about externalising, being able to hold that information in our head. So there are little things you can do that make life for children who have working memory deficits an awful lot easier. So I've talked about this before, so very briefly, is the acetylcholines. It's those neurotransmitters within our brain. We need to increase, just using rosemary and peppermint essential oils, even drinking peppermint tea can help improve our working memory. Barefoot running, there's some great research that just 16 minutes of barefoot running can increase that blood flow to our prefrontal cortex. And of course, diet. Now, essential oils and barefoot running are far more immediate. Diet, it takes a little bit longer. So we're talking about the flavonoids, and these can be found. You can find lots more information on this. Citrus fruits, interestingly, dark chocolate, which is always a nice one. And it just is about increasing those biochemical pathways within our brain to increase that learning and memory connection. And then I'm just going to leave you with why it's important. Why do we need to reduce that cognitive load? Why do we need to think about increasing our working memory and helping these children? And that's because working memory predicts school performance later in life, far more so than IQ alone. Working memory in preschoolers has been shown to predict future risk of dropping out of high school. Children with reading and math difficulties often exhibit working memory deficits, so these are the children we need to help. These are the children we need to target. Developmental studies of children with poor working memory have also reported findings to suggest that the effects of this are cumulative across development, and this results in greater issues with learning as the children get older. And then we really need to think about early intervention. We need to think about all this continued professional development for teachers so that they can identify children who have working memory deficits early, and we can externalise those working memory. We can think about how else we can help these children so that, they are not going to drop out of high school, that they are not going to have this accumulative effect of problematic learning, and that, they are going to succeed, because a lot of these children are incredibly bright. They just need a little bit of help and information presented to them in a different way. So working memory is incredibly important within the classroom.